This is example 2.9 on page 77. And this is an example of utilizing the mole concepts that we've been learning and combining them with using math equations. So here it says an aluminum sphere contains 8.55 times 10 to the 22nd aluminum atoms. What is the sphere's radius in centimeters? And they gave us the density of aluminum as well as the volume equation for a sphere. So the general strategy for this is we're given this number of atoms. So we're going to start with atoms. We're going to convert those to moles using Avogadro's number. Once we're in moles, we can convert to grams using our molar mass. And then once we're in grams, we have a common unit with the density. So we can use the density to get to volume, technically in centimeters cubed. So we're going to be using density there. Then, once we have the volume, we can plug that in to our volume equation and solve for radius. Seems simple enough, hopefully. We'll be able to get there. So remember Avogadro's number, 1 mole is equal to 6.022 times 10 to 23rd atoms. The molar mass of aluminum, if you consult a periodic table, is 26.98 grams per mole. Density we're given in the problem, 2.7 grams per centimeters cubed. And then we're going to plug that in once we find volume to solve for radius. So, let's recap. We're given number of aluminum atoms, and we're trying to find radius in centimeters. So, our first part, we're looking for volume. So I have my 8.55 times 10 to the 22nd atoms of aluminum down here. To convert first between atoms and moles, we're going to use Avogadro's number. So on the bottom is going to go our atoms, 6.022 times 10 to the 23rd in 1 mole up top. That's going to cancel atoms. And then we're going to be in moles of aluminum. We're going to use its molar mass. So on the bottom, 1 mole of aluminum, because that's what we're trying to cancel, contains 26.98 grams of aluminum. So then we're going to cancel moles. And then we're in grams, and we want to relate grams to volume, so we're going to use the density. Remember that bottom centimeters cubed is an understood 1 next to it. So what we want to cancel goes on the bottom, 2.70 grams of aluminum, and on top, 1 centimeter cubed. So that means grams cancel, we're left with centimeters cubed. That's what we want for this part. So if we multiply across 8.55 times 10 to the 22nd times 26.98, take that number, divide it by 6.022 times 10 to the 23rd, and divide that by 2.7 grams, you should get 1.4187 centimeters cubed. So now, clear the slide, we have our volume in centimeters cubed, and we're going to plug that in and solve for radius. And our radius is ultimately going to be in units of centimeters. So we need to rearrange our equation. So I'm going to multiply both sides by radius. So that's going to be our 3v equals 4 over 3 pi. And then I'm going to divide by v. So r cubed equals 4/3 pi v. And then I'm going to take the cubed root of that so that I get r is equal to cubed root of 4 over 3 pi divided by v. And v, remember, is 1.4187 centimeters cubed. So if I take the cubed root of that, 1.4187 centimeters cubed root, that gets rid of the cubed there. If I plug in that number and take 4 over 3 pi divided by that number and then take the cubed root, you should get that r is equal to 0.697 centimeters. So the radius of this aluminum sphere is 0.697 centimeters, and that is your final answer.